Good morning, good afternoon, good evening, wherever you may be. Welcome to the Database In-Memory Office Hours. My name is Maria Colgan, and I would love to introduce our host today, which is Andy Rivenes. Andy, over to you.
Thanks, Maria. Another one of our Database In-Memory Office Hours sessions. So today I thought it would be interesting to dive a little bit into In-Memory Vectorized Joins, which is a new feature in 21C for Database In-Memory. And significant, I think you'll be impressed, but it significantly improves hash join performance. And so we'll kind of talk a little bit about how all that works and hopefully convince you that we're making some good progress, and maybe you can try out Database In-Memory if you haven't yet. So our office hours pages, I'd be remiss if I didn't point out, so there's our experts there, but that we do, if you want to go back and look at any of our other previous sessions, we have a list of all of our other sessions. There's a whole bunch of them. You can go through and look at that. Also, resources, if you want to discover more about Database In-Memory, our blog, and in a resources page, which I'll show you in a second. Customer stories, In-Memory Advisor, if you want to see if maybe you have analytic workload that could take advantage of Database In-Memory, and our Live Labs environment. So if you want to go try out Database In-Memory and don't want to maybe download it or download 21C, you can just literally run Database In-Memory on our cloud and try out Database In-Memory, kind of our hands-on lab. So you have all sorts of SQL scripts you can run to discover how much faster Database In-Memory is than not having it. So I think that takes care of that business. I do want to show our resources page in case I forget. From our blog, you can get to our, I guess I can just go back and do it. From our blog, blogs.oracle.com/in-memory. And then if you hit this little button up here, we have a resources page, which if you're interested in Database In-Memory, we have all sorts of technical information. If you're running different applications, but videos, links to our AskTOM Office Hours, in addition to our Live Labs, and if you want to try to run things on your own. And we even have some information on patches, licensing, and some of our friends and their related blogs. So you may hear me mention the resources page, and this is actually what I'm talking about. So with that, it would be remiss if I didn't talk about that as well. We'll get started. So I'm going to go to maybe, there we go. I'll just go to full screen mode. We're going to do I'll just do a couple of slides to give you some quick background. Then we're going to jump into a demo, and hopefully my VirtualBox will stay running, and I can kind of show you how In-Memory Vectorized Joins actually work. And as always, we should have plenty of time to talk about anything else in addition to the new 21C features if you have other questions about Database In-Memory. There's my email address and my Twitter handle. You can also follow Maria on SQL Maria for her Twitter handle, and she also has a blog. I guess I should put that up there, huh, Maria? Your blog in there as well. But you can find it if you follow her on Twitter. She's fairly regular on posting blog posts. So with that, we'll kind of get started. In-Memory Vectorized Joins. So I did actually talk about this. So I have a couple of slides from our 21C new features where we kind of went through all of the features, and I have a new blog post out that talks about it. There's actually we made quite a few changes or additions to Database In-Memory in 21C. So it's there's a lot. So this is one of the ones I think is pretty exciting, this and automatic in-memory, which we've talked about. So that's one of the reasons I wanted to do it now. To kind of go over this. The gist of this is that we're leveraging single instruction, multiple data, SIMD vector processing to further enhance our hash join processing. So when we go through and compare values for probing between the two tables, and I'll show you a couple slides of where this fits, we can significantly speed that up. And so really the idea is that we're optimizing hash joins. This is part of an in-memory vectorization framework. So this is the first of more things to come, if you will. But this is one of the first features to take advantage of this framework that's been developed to allow us to further leverage essentially array processing. If you think about it, well, not new, I guess, Intel chips have the ability and Spark Solaris to do SIMD, single instruction multiple data. And so this is a further journey in enhancing database and memory support of SIMD vector processing. It's all about hash joins. I would be remiss if I didn't point out that it doesn't require the latest SIMD vector support in your CPU chips, but I discovered one of the many things I discovered in doing this demo was that some of the older chips won't get anywhere near as much benefit from the in-memory vectorization as the newer AVX support that's in most modern server level, and to be honest, even on my laptop, my Mac supports AVX. So there's AVX, AVX2, AVX 512. If you're interested in SIMD, go Google for it. There's lots of information out there. But you won't get the maximum benefit, which I discovered, unless you're using the AVX instruction sets. Also, we leverage, and a lot of things with database and memory are this way. If you think about it, we have different, database and memory leverages different features of Oracle database. Some of the things that in-memory vectorized joins will also leverage, and we'll talk a little bit about this, is join groups, something that a feature of database and memory introduced in 12.2. IMDS, or in-memory dynamic scans, which helps parallelize scan performance at the IMCU level. We've talked about that as well. And ultimately, over a non-in-memory hash join, we can get some really big performance improvements using all of these things together. And so I wanted to make sure I kind of give the details of some of this support so that you're clear on some of the things you can think about when if you want to try out and use in-memory vectorized joins. So I'm going to really quickly just review a hash join, and all I really want to do is make it clear that ultimately we're going to join, in traditional thinking, two tables, usually a smaller table to a larger table, and the takeaway here is really just that ultimately we build a hash table in the PGA based on the smaller table, and then we use the larger table, we probe that hash table to see where we have a join match. And so that's kind of just the only thing I wanted to cover, because we've talked about this in depth in previous AskTOM sessions and even in the 21C new features. And with database and memory, we enhance that with the ability to not only scan the tables in the column store, so that makes it faster. We also support for filter predicates on the dimension table or the smaller tables, Bloom filters. And so we can pass Bloom filters into the larger table as an additional filter predicate, so we get even fewer rows to then match against the hash table in the PGA. And so that makes in-memory hash joins can be much, much faster than a traditional row-based hash join. And then for our purposes today, in-memory vectorized joins fit in this area where we're doing the comparison between the two tables on the join key. And so here we use SIMD vector processing to make that essentially, I'll say when we do our scan processing, array processing, we can scan many more rows and compare values using SIMD vector processing. And the same is true with the hash join and being able to use essentially array processing to compare multiple rows between the two tables in single instructions, if you will, which is where we're getting huge speed up. And that's what the demo is going to be about. So I want to show you that in action. So it's fine to kind of do the conceptual part, but sometimes it's easier just to see, oh, that's really fast. Here's what I can look for to figure out whether I used it. I'm good to go. So not everybody needs to understand all of the inner workings of these things to take advantage of them. Couple of other housekeeping pieces. There is an in-memory deep vectorization initialization parameter. You don't have to know about this. We default it to true, which in basically all cases, you're going to want to use it if it's available, the optimizer. It's actually a runtime decision in the SQL execution, whether it's going to actually be able to leverage this. And so for the most part, it stays true, and you don't have to worry about it. However, like all things with Oracle, there's choices. And for our purposes, we're going to set it to false a couple of times to show the difference. So it's kind of like comparing apples to apples, say, or, with it, where are the benefits? Are we really getting benefit from in-memory vectorized joins? So in the scripts, we'll see in-memory deep vectorization. I'll set it to true and then to false, and we'll do a little bit of a comparison. So that's kind of for the demo. Normally, you just leave it to true and just take advantage of the speed up. How do you figure out whether you made use of it? So we're going to talk a little bit about this. There are some statistics that you can see in from VDOL or this systats, basically, or yeah, systats. But in the binoculars, in a SQL Monitor active report, you can actually click on the hash join for your in-memory. Notice I have table access in-memory full, and here I'm joining the line order and the date dimension table. Created Bloom filters. So we had a filter predicate on our date dimension table. But if I click the binoculars, I can see, notice deep vec hash joins and deep vec hash join flags. So that tells us that we used in-memory vectorization or vectorized joins, sorry. And very similar to join groups, which actually we'll show you as well, because we're going to compare join group performance with in-memory vectorized joins. So that's even a further enhancement. But it's not clear, or maybe it's not as obvious. It doesn't say in-memory vectorized joins, yes, but deep vec hash joins basically tells you deep vectorization, and that's what is going on under the covers. So you can tell without having to go dive into a bunch of other things. If SQL Monitor Active Report, you can see that you use database in memory, you can see the benefit you got from timing, and then you can click and see if I used any of these other features, and in this case, deep vec tells you you used an in-memory vectorized join. Anything else, Maria? I think I'm trying to do the overview there.
No, I think we've covered everything that we need before we jump into the demo. Just to reiterate one point, based on what you were saying there about the parameter and everything, there's nothing I need to do. If the optimizer or if Oracle decides that my query can benefit from one of these vectorized joins, it should just automatically happen for me, right?
Yes, yes. And that's really what we're trying to do with all of data. Once you enable database in memory, you don't have to change your SQL, you just run. And yeah, so deep vectorization or in-memory vectorized joins, I want to say deep vectorization, but in-memory vectorized joins just work right out of the box. You enable in memory, and if the optimizer chooses an in-memory plan, if at runtime, it's going to make sense. We do some work under the covers to make sure that your query is actually going to be faster. We don't want to slow you down, and it just all automatically happens. And that's kind of where we're really headed with all of the in-memory features. Even AIM, we're trying to avoid you having to figure out alter table in memory. So yeah, so we're really focused on making this all automatic, and this is one of the features where you don't have to do anything to take advantage of it. So with that, we'll dispense with slides, and since they're kind of boring anyways. And let's see, so here's my VirtualBox, and so I've got 21.3. I literally downloaded it off of oracle.com. Same thing you can do. Set it up if you want to set it up in VirtualBox or maybe on your systems. Remember 21C, you can use the base level feature if you want to try out database in memory. So you get up to a 16 gigabyte column store. This will work with it. This works with the base level feature. So if you want to try it out in a more formal environment with more representative data, feel free to try that to do that. But is the screen big enough, Maria, or should I make it bigger? I think people can see that.
I can see it pretty well, yeah. I did get one question that I'm answering on the Q&A now, but I'd love your input on it, Andy, while I'm interrupting anyway. There's no plan to backport this to 19C, is there?
No, there isn't. Boy, we get that question a lot, and that's not just me, but lots of folks I think are getting that question. No, the story there, just real quick, is that 19C is really supposed to be the long-time stable release. We did backport things like the base level feature, but the idea is we're 21C is an innovation release, and moving forward, and really that's where we're looking to add the new features. So trying to move some of the stuff into the previous releases, the base level feature was easy because that was pretty much just, reducing the size of the column store and not tracking licensing. But this kind of stuff, there's a lot of stuff going on under the covers, and we don't want to introduce the possibility of disrupting the long-term aspects and the stability of 19C. So that's not going to happen. We're not going to backport this or most of the new features in 21C for database and memory, simply because it would introduce too much risk. Hopefully that answers that question. I'm sure that's the same thing you said. So anyways.
Far nicer than I did, but yes.
So we have our SSB schema. So I'll just show it to you. I've only literally populated 2 tables just to make it easier, because I'm gonna show you the examples with just the simplest hash join. We have basically just 2 table hash join. And so just customer and line order, the 2 tables from our SSB schema that we normally use. They're already populated. As I said, this is 21.3, literally downloaded not last week, but the week before, or like the Friday when it came out, off of oracle.com. So it's the same production version that you can try on premises or in the cloud. And so there's nothing hidden there, just Oracle database. And so what I wanted to do first is I'll just run a query, just basically using the same scripts that we would normally use for our hands-on labs. And it's just, as you can see, it's just a join between the line order table, the customer table, and it runs in 2.5 seconds. We see it just does a hash join in memory full. We don't have any Bloom filters, no filter predicates. And really the idea here was just to see how focus on just the hash join and the longest I can make it run so that we can see hopefully the benefits. 2.5 seconds isn't super long, but it's long enough that we're not in like down into sub-second timings where the margin of error could affect, seeing the benefits. And then the statistics. And so we see that we did our in-memory scan. We have, if we've talked about this in the past, we have 112 IMCUs that make up the line order table in this case. And so we see that we've done an in-memory scan. And then let me show you that same query. And what I've done is I've disabled in-memory vectorized joins. That's a mouthful, just to show you the difference. And so notice that I've taken that parameter that I mentioned and I've set it to false, so that we're not going to take advantage of in-memory vectorized joins. And now we see that the total time is almost 9 seconds, 8.89, almost 9 seconds. The previous query ran in 2.5 seconds, now almost 9 seconds. So it made a significant difference. And it's the same query, same execution plan, literally the same plan hash value. If you look at that one versus this one, it's the same exact plan. And then we can look at the statistics. We're still doing an in-memory scan. So all of that remains the same, but it was way faster. So in looking at these scripts, and this is literally the same script I run for all of the hands-on lab scripts. It's the same format, the query, the explain plan, and then the $MyStat, the statistics. And actually, I should show that because that leads into my first discovery when I was doing all this. But notice I just list a bunch of CPU, but in-memory scans and some other scans like physical reads to show that we're not going to disk, we're actually running out of memory. And and then some of the other IM. Notice I've got this in here as well. So this script I've been using the scripts for quite a few years. It works on 19C. It's the same exact script. But when I was working on this, I mean, one of the things I said at the very beginning was part of the reason the in-memory vectorization framework is so interesting is because we're leveraging SIMD, but yet I don't see any SIMD statistics here. So on this one, I guess maybe that would be acceptable because we disabled the memory vectorized joins, but in this query, I don't see it there either. So this led me to some discoveries that currently there are problems with $MyStat. So that's where, notice I'm using $MyStat. So I went and looked at the system statistics, and then lo and behold, the SIMD instructions or statistics show up. And so I said, oh, wow, now I've got to change a bunch of stuff. So to make a long story a little shorter, I basically remembered that in the old days, Tom Kite, who actually the AskTOM originally was based on him. Now it's the Oracle Masters, I guess. But anyways, good old Tom Kite had a utility called RunStats. And so I had modified that a while back, and I modified it a little further to take advantage of system level statistics, which work fine for this case because I'm the only one using the database. Wouldn't necessarily be good in a multi-user environment, but again, it's just a demo because I wanted to show you the advantages of in-memory vectorized joins and what we're doing with SIMD vector processing. So all that was a long story to say that we're going to run another script in a little different manner than we normally do. And so it's this third guy. And so it's basically the same two queries. Notice I've set deep vectorization to false. We're running that query. And then we're going to run it with deep vectorization true. And we'll run the same query. And we get some statistics here. And I'm going to go over this in a second. But notice all of a sudden, all of our SIMD stats show up. Lo and behold. So that's kind of cool. So again, I've bugged the problem with $MyStat for us. We're not seeing the in-memory SIMD stats, and so hopefully we'll get that fixed fairly quickly. But it's just one of those things that happens. So notice that all I did was I marked in I marked run stats, and I marked a start. I have a middle, and I have an end. And at the end, we just basically compare the first set of statistics to the second set of statistics and then show you the difference. And here we can see that, remember I ran the first query. I guess I'll just show it to you. Remember I set it to false. It ran in our 8 seconds. Then I ran the second query with it true, and it ran, in this case, 3 seconds. Before it was 2.5, but way faster, more than double or less than double the time, or less than half the time, twice as fast. But now notice that if we look at our statistics, SIMD KV key value, these are the key statistics that actually are new for in-memory vectorized joins. And notice that it was 0 when we disabled vectorized joins. And now we have really big values when we enable vectorized joins. And we can see the results in the time. And so that's kind of under the covers how you can see that whether we leverage those SIMD instructions and the benefit we got in running the query. One other thing I'm going to point out, because I've talked about this, and I know Maria was getting ready to tell me this. We've talked about this in our previous sessions about IM scan rows projected and the benefits that we can see when we do more work during the scan of the IMCUs and only have to return results back rather than all of the rows. And that's part of how we get so much faster. If you recall, and I remembered to tell you at the beginning, I said we had 112 IMCUs. Actually, there was a combination of line order and customer. And here we see that without in-memory vectorized joins, we return 60 million of those rows back to the upper layer to do the hash join processing. Whereas with the run with in-memory vectorized joins enabled, we only have 111. So we did all of that work to do that hash join processing while we were scanning the in-memory compression units, or IMCUs. Again, this in combination with these guys, sorry, I missed one. These guys basically shows you that, or basically allows you, I think, to see why we went from 8 seconds to 3 or 2.5 seconds. Does that make sense, Maria? Do you think I didn't confuse everybody, hopefully?
No, it makes perfect sense, but it has triggered a number of questions for you. So
okay.
Let me start going through them. First one, as always, it revolves around licensing. Can I take advantage of vector joins in the base level database in memory?
Yes. I did try to say that. And so, yes. So this isn't something we turn off if you use the base level feature. So you can take advantage, 21C, base level feature, yes. Although
awesome.
to be honest, yeah, so yes.
The second one, and I had the same question myself actually as you were going through the demo, where can I get all of your scripts, including run stats, which seemed to be really popular question that came up from multiple viewers.
Well, okay, so that actually is, you know, to be honest, I spent a lot of time trying to make this all understandable, if you will. Run stats, if you Google for run stats, you might find it, but I used to have the version that I use, which is a little bit easier, a little more user-friendly, that Tom had posted on his original site. I don't know that site exists any longer. So
no, unfortunately it doesn't.
It doesn't, okay.
No.
So those are all gone. So I will, so I have, and I have a link on the resources page. Again, there's another plug for that. The GitHub. So I will, and I haven't done it, I will. I have it all ready to go. I will post the original run stats and then this version that I'm using, run sysstats, on GitHub, and I'll put the scripts on there too. I didn't do it. I did want to do it, and I just didn't get to it. There's been so many things going on that I just haven't, and I will do that as we post the video, which will take a day or two. I will get that out there as well, so that, yes, the idea is you guys should be able to try this on this data, because SSB schema, everything. So I will make all of this available on GitHub. So that's the answer, I guess.
No, that's awesome. And we'll have a link to that GitHub repository, I'm guessing, on the resource page on the blog.
And I'll probably put a little...
And in the bit under the video as well, I'm guessing.
Yeah. I've been in the habit of, when I make mistakes or have more information, I'll put a big bubble in there so that you'll see, oh, okay, I can just go to the GitHub and we'll make that available. Because really the idea here is that you should be able to go try this out and say, oh yeah, this is great. We really, this could tip the scales in favor of us wanting to really try out database in memory. I'm going to do, so I mentioned join groups, and so I'm going to do some work right now to get the next set of demos running. So, because we need to, I'm going to create a join group, and you can see it there. We've talked about join groups in the past. And I'm going to get the repopulation, because when we create a join group, then we have to repopulate the tables involved in that join group to get the common dictionary values populated in the column store. If any of that doesn't make sense, we did do an Ask Tom session on join groups. Go back and take a look. That would be my recommendation. But I'm getting that going so that, and I'll make sure our population goes. Yeah, so we're populating. While we talk about the next subject, which what I wanted to cover, unless there was other questions, Maria.
There are, but I've got them covered. You keep going.
Okay. Yeah, because as usual, we're going to probably, hopefully we won't run out of time. But so I mentioned SQL Monitor active reports, an easy way to see not only the benefit of database and memory, but also whether you used in-memory vectorized joins. And so here's a query that I ran, and it's just the SQL Monitor report. In the interest of time, trying to generate the SQL Monitor report, copy it over to my laptop so I can get the browser to run, it was just too much effort. So what I did is I just pre-created these literally off of this environment. And so here we see that in this case, it ran in 1.22 seconds, but in memory full, our hash join customer line order table, hopefully everybody can see this. And if I click on the binoculars, I see that I use deep vec hash joins. So that's set to 1. So that's to tell us that, not only did we run really fast, we used in-memory. Remember, you can hover over things like the activity bar and here as well. We ran fast, and we see that for the hash join, we took advantage of in-memory vectorized joins. So that was the second script I ran. The first script I ran was without in-memory vectorized joins enabled, and that runs slower, 2.86 seconds. And actually, it's funny because today it's running slower than it ran when I tested and created these. But really the only issue here is recognizing that I can click on this and see that no deep vec hash joins. So you can see this in the SQL Monitor Active report. I'll admit that this isn't it would be nicer if it just flashed up somewhere. We used in-memory vectorized joins, but that's not how it works with SQL Monitor. But the information is available in a SQL Monitor Active report. So I wanted to point that out. We'll take a look at the next set in a second, but hopefully that's clear. And again, I know Maria does the same thing. We highly recommend using SQL Monitor Active reports to evaluate your queries. You can see where time is spent. Notice here, we spent our time CPU. We actually spent, in this case, all of our time on the hash join. Even though we did in-memory scans, they were so fast that really all of the time was consumed in the hash join. So that would be the place where we might want to optimize our query. And lo and behold, with in-memory vectorization, that's exactly what happens. So we've eliminated that. Now all of our time is just literally spent scanning the line order table, much less of it on top of that. And so we've gotten the maximum benefit from our query by fully leveraging database and memory. So with that, I will go back to the query. Hopefully this thing is populated. Almost, it's getting there. So let's see. What else we were gonna talk about with our delay here, Maria? Do you remember? It was something else I was going to mention.
I don't remember what we thought we were going to talk about, but I do have a couple of things that I think we should hit on just based on what's coming in via the Q&A. Cool. So just to reiterate, the optimization we're talking about now is for hash joins, right?
Yes, it's just focused on just hash joins. So hash join performance.
Yeah. So the question came in with, is this more for transaction processing or data warehousing? And so I was explaining in my answer that you see it more for analytics and reporting, but generally hash joins is really the place. Right. So if you've got a hash join, regardless of the workload type, you could see some benefit from this. Yeah.
So to reiterate, database and memory, we really do focus on analytic processing, whether it's mixed workload, so OLTP and analytic reporting, or perhaps data warehousing, which is more focused on analytic reporting. And I always tell folks, since we're waiting for things to happen, and to kind of answer that question, database and memory is going to speed up scan and filter operations, hash join operations, and this is another even further speed up of focusing strictly on the hash join performance, and then group by aggregation performance. So those are the three big areas that database and memory targets in your SQL execution. And so if you have time being dominated by those three areas in your execution plan, database and memory is probably going to help significantly. We're not speeding up sorting at this point. If you're doing row by row processing, all those things we've talked about in the past, but really this is focused on strictly on hash join performance.
Perfect. Now, is that enough time, or do we? Oh no, I'll stop talking.
No, we can. Go ahead if you have a question.
Just one more.
Sure.
You mentioned the fact that you've downloaded 21C. Folks were asking if they wanted to try it out without having to do the download of the VirtualBox. Can they test it out on DBMS, the database cloud service, 21C on the database cloud service?
As long as it's the extreme performance or Exadata flavors, which is where database and memory is currently available on the cloud. And if it's 21.3, yeah, absolutely.
Okay, cool.
So recall that reason when I did and we had this little delay was that I had created a join group. So I created a join group to further optimize the dictionary encoded values for our join key between our line order table and our customer table. And again, we talked about join groups in the past. And so then I had to repopulate, and actually I could rerun this, because notice that the global dictionary address isn't there. And now it is there because we've repopulated our tables. So we know that the join group is been created. We've repopulated our tables. We see that here in the column store. So now what we're going to do is we're going to take a look at in-memory vectorized joins with join groups together, because we said that they work together. And so what I'm going to do is I'm literally just going to rerun our sysstats query that we ran before, where I turn off in-memory vectorized joins, and I turn it back on, and we run it twice. And so I'm just going to run that. I'm going to cross our fingers. So this is with in-memory vectorized joins false. This is the first query. Notice it's quite a bit faster, 2.9 seconds. Previously, it was running in about 8 seconds. And so now, just join groups has given us a significant benefit. And that makes sense if you think about it, because in most of the work in strictly a hash join is in comparison in the probe table, or probing the probe table and comparing the join keys. And so there's a lot of work there. And so if we're having to figure out the different hash values, making them common so we can operate directly on the dictionary encoded values can provide a significant speed up. And we see that here. And that's join groups. If we add in-memory vectorized joins, notice I've said in-memory deep vectorization is now true. Look at that, 0.75. So we went from 8 to 2 with just join groups, and then with in-memory vectorized joins, we went from basically 2 but 3, somewhere in that range, 2 to 3 seconds, to 0.75. So these things work together, and we've seen huge improvement in our performance. And think if you're running gigabytes, tables that are in gigabytes of size, hundreds of megabytes, gigabytes, the time there is going to be huge. I mean, this is just my little laptop. And so as we get larger in size, we scale the data out, the performance impact becomes even greater, in the sense that now we're talking going from minutes to possibly seconds or fewer minutes. And then in our statistics, we still see that we made use of all of our key value SIMD processing that occurs. And how do we tell whether we used the join group? So we go back to our SQL Monitor Active Report. That's the only way I know of that's practical to show that join groups were used. And I don't remember, I think this one is the one where, so I've got the same hash join. Probably should have put these in different order so I don't get confused. But in the SQL Monitor Active Report for the hash join, when I click on the binoculars there, notice it says columnar encodings leveraged. So that's how you know that you used a join group. So it is what it is. And then the query that I ran, notice it's 0.36. Here it was like 0.75. For some reason, when I was running it, the virtual box, it was faster, but it's, again, not really that important. Here, though, this is kind of a harder thing to deal with. We use deep vectors, so we see deep vector hash joins, but we lost all of the information about join groups. I asked the developers, and this is just essentially, I don't know that there's a technical reason other than it might be an oversight. However, in order to get this information, we actually, at runtime, we overload some bit vectors that get passed back into ASH data in the SQL Monitor tables. And so it may be that there's a limitation on how much data they can pass back. Maria and I were talking, and that was her hypothesis, and sounded pretty good to me. So I will follow up on that. I don't know if it's a bug or it's just not possible to do. We do see that we used vectorized joins. And to be honest, the bottom line is it was way faster, and that's really what's the important part. So we've set up join groups. We've kept the in-memory vectorized joins. We've enabled, we don't have the parameter set to false. You don't have to do anything other than, you do have to create the join group currently if you want to get the added benefit. But you don't have to do anything to take advantage of in-memory vectorized joins, and again, 21.3. So together, these things work and give us, I mean, we went from basically 8 seconds on an in-memory hash join all the way down to I'll use the number here, 0.75, less than a second. That's some pretty dramatic performance improvements, in my opinion, for hash joins. We made it through, and now if it crashes, it doesn't matter. So I got the demo done. I was having trouble with my VirtualBox crashing, and I believe that's everything I wanted to cover. It is. So we're good to go. Oh no, actually, there was one more thing we were gonna show. Hopefully I didn't jinx myself. So there is normally when we run our hash joins, we have a filter predicate. So we show Bloom filter support. So the question might be, I don't know if anybody asked this yet, do we support Bloom filters and all the other stuff we're doing with optimizing hash joins with in-memory vectorized joins? And the answer we'll find out in a second. Whoops. Oh, what is that? That's
your run stats. That's your server output on.
Yeah, so let's see if this helps. Although I reconnected before. But it might be, yeah, so let's see if that, I might have spoke too soon, but what we're supposed to see is, yay, thank you, is that all I've done is I've taken the same query we were running, and I've added a filter predicate to say, I only want to see the America region. And there's like 5 or 6 regions in the SSB schema under the customer table. And so that generated what we normally would show, what I would normally show with Bloom hash joins, is we have a Bloom filter. So we're gonna take further advantage of filtering the rows before we do our hash join. And so then what I'll show you is, customer with filter. And the reason I didn't just do this right off the bat is because this stuff runs so fast. Now notice we went from running the query in, well, let's see, where was the first one? I went right by it. So the first one ran in 1 second, and the second one runs in 0.59. And so really the takeaway is because we're looking at less data because we filtered a bunch of data out. And so what I wanted to show was the longest runtime I could get to show the maximum benefit of just a hash join. But the takeaway here is that these in-memory vectorized joins works with filter predicates. So we're not limiting you. You just run your application SQL, and we'll take advantage of these new features in 21C. So I remembered that, and we're actually, I think, doing good for timing as well. So now it doesn't matter. So now we're good. Any questions? Anything you want to add, Maria?
No, that was the thing I was going to jump in with, was that what happens if I have filters? Because as you said, most analytical style queries, they'll be a little bit more complex than a simple hash, 2-table hash join. Yeah. But honestly, I think this is fantastic. The fact that I'll get this acceleration automatically is great. Now I say that, and of course a question has just popped in, so let me just take a look at that. Do you know if there's a plan to introduce a specific database cloud service shape just for DBIM? So perhaps one that's got more memory.
Very interesting. We are actually, I'll let the cat out of the bag. We're talking about it. I don't know if it will happen, but we would like to have that. One way or the other, we're making some progress in our roadmap to fully enable database and memory in the cloud in autonomous database. And as part of all that, we would like to be able to offer more memory, obviously, so that you could run the column store. I don't know what's going to happen with all that, but we are talking about it. So the answer to your question is yes. What will come out of that, I cannot say. But we are definitely, that's the direction, since we believe database and memory and this kind of performance improvement is so key to a lot of customers and their analytic workload, that we want to make that, basically you don't have to do anything and it all just works. And that's kind of where Oracle and Oracle Database has been headed, to making your applications simple to run. So anyways, before I stick my foot in my mouth, I won't say any more.
No, well, you said more than me, because the autonomous database question also came up. I did answer it in the Q&A there, where I said that ADW does already take advantage of the database in-memory acceleration at the Exadata storage tier, where we utilize it in the flash cache, and that we were working on making it available in main memory for customers. So I think we can leave it at we're working on it.
Yes. And that's fair. So I think people understand how that works.
ADW does already, like I say, automatically use it. So
so cell memory, it already takes advantage of that. And that's actually one of the things in 21C, if you go back and look at the blog post, even on your Exadata environments, whether on premises or in the cloud, the ones that you might run, we have an option to say, just use cell memory if perhaps you are memory constrained in those environments, and even on premises as well. Personally, I think it's really a combination for folks, Exadata folks, being able to leverage the in-memory and then cell memory to expand your analytic footprint is a better way to go. But there are folks that are, I tell people that are commodity folks, the in-memory part of this is you have to add memory to take advantage of it. And lots of our Oracle database customers are what I would say memory constrained. And so you keep trying to give people different options and flavors of what they can do to take use of the product. So I did it. I did another long-winded answer. Sorry.
No, you're good. I couldn't find the unmute button. So, but with that, we have addressed all of the questions that have come in, and excellent. We're already 5 minutes over. So I just want to make sure that we wrap up on time. But if there's anything else you want to add, Andy, before we let everybody go? No,
I think the only thing, remember the resources page. We have the blog URL. I promise I will put the run stats and the sysstat version of it on GitHub, which I believe there's a link. I have a link to this somewhere in here. I should highlight it, and that's other technical links. Here I say hands-on lab. So I already have this in right there. Sorry. In GitHub. So I have office hours scripts. So you can just click on that link and I will get it there. In addition, it usually takes me a day or two at least to get this put up. I will put a little box in there so that you can try this out for yourselves. Because really there isn't anything, this isn't, I don't want to say rocket science, but it isn't a complicated query. It's a hash join. So it's really easy to see the benefits. And then with the base level feature, or if you're licensed for in-memory, you can, and you've downloaded or are willing to try 21.3, you could actually try this on real data. And if you do that and you would like to send me a note, tell me your results, I would love to hear feedback from that. And so feel free. We have, at the beginning, I had my email address. I'd like to hear, your thoughts. So that's part of the office hours thing. So with that, that's kind of all I had. Awesome. Well, thanks so much for joining us today, folks. We'll get the video posted shortly, as well as those extra scripts on the GitHub there that you see. So thanks a million, Andy. Really appreciate your time today and such a great informative session on the new vector joins. Well, thank you. And thank you, Maria, for all your help. It always makes this go much smoother. So, and with that, I guess we're done. All right. Thanks, folks.